You now have a growing pile of useful functions. This lesson is about turning that pile into a proper, reusable PowerShell module, a manifest, controlled exports, real error handling, logging, retries, and tests. This is the difference between scripts that live on one technician's laptop and automation the whole team can depend on. Once you have more than a handful of functions, copy-pasting them between scripts becomes a liability. A PowerShell module packages related functions so others can import-module them and call your work like built-in cmlets. A script module is two files, a .psm1 holding the code, and a .psd1, the manifest, that declares metadata, version, dependencies, and what the module exports. Folder name, module name, and root module should all line up. Generate the manifest with new -module manifest, and never hand-edit the auto-generated GUID. Set a module version and bump it whenever you change the module, because version numbers are how runbooks and other scripts pin to a known good build. Declare required modules so your dependencies, like Microsoft.graph.authentication, install automatically. And list functions to export explicitly, which leads us to the next point, deciding what is public. Not everything should be callable from outside your module. Only the functions you export are public. Everything else stays private to the module scope and acts as an internal helper. You control this with functions to export in the manifest or Export-ModuleMember in the PSM1. Keep your public surface small and intentional, because every public function is a promise you have to keep stable. Helpers like write-log and invoke- with retry stay internal. Generic, opaque failures waste hours of someone's life. Throw meaningful error records that carry a category and a target object, so callers can catch a specific type and operators get real context. Use try-catch finally, and when you catch an error, rethrow it with added detail rather than swallowing it. A caught error you ignore is a future incident. Here we surface which device failed and why, with an object not found category that a caller can branch on. Give your module one internal logging function that every public function uses. Timestamp and level each message, and route it through write-verbose rather than write-host. Why? Because a module is consumed by other scripts and runbooks where there may be no screen at all. Write-host writes straight to a host and cannot be captured or toggled, but write-verbose lets callers switch detail on with -verbose and redirect or persist the log. Controllable output is the whole point. Network and graph calls fail intermittently, so give your module a retry with backoff helper. It runs an action, and if it throws, it waits and tries again, increasing the delay after each failure, 2 seconds, then 4, then 8. That exponential backoff stops you hammering a service that is throttling or temporarily down, giving it room to recover. On the final attempt it rethrows so a genuine failure still surfaces. Now any public function can wrap a flaky graph call and invoke - with retry and get resilience for free. A module you cannot test is a module you cannot safely change. Pester is the PowerShell testing framework. You describe a function, write it blocks for each behavior, and use should assertions to check the result. The killer feature is mock, which lets you replace a graph cmlet with a fake that returns whatever you want, so your tests never touch a live tenant. Here we mock the managed device call to return nothing and assert our function throws. Now you can refactor with confidence. Let us recap. A module is a PSM1 of code plus a PSD1 manifest, generated with new -module manifest. Export only your public functions and keep helpers like write-log and invoke- with retry internal. Throw meaningful error records, log through write-verbose, and wrap flaky calls in retry with backoff. And protect it all with Pester. Your task: turn at least 2 earlier functions into a module called endpoint ops, generate the manifest, export only the public functions, wrap a graph call and invoke- with retry, add write-log, and write one Pester test that mocks the graph cmlet and asserts a throw when no device is found. See you in Lesson 7.